Hi, this is Maggie. In this video we're going to create a simple Java class in Eclipse. We'll discuss creating the class from a UML class diagram specification, creating Javadoc for the class, and writing a client program that will demonstrate creating objects of the class and sending them messages. The class we're going to implement is called Proverb. This class is part of a larger system which is designed to be a networked game in which players are presented with the start of a proverb. For example, an old Klingon proverb states, "If you cannot control yourself," and then the players each complete the rest of the proverb. They are then presented with all of the completed proverbs, including the correct one, and they guess which is the correct proverb. Points are awarded for a correct guess, and when another player incorrectly identifies your proverb as the correct one. Naturally, this game is usually played with obscure or unfamiliar proverbs. And I do think a Star Trek, Star Wars, or Lord of the Rings edition would be fun. I'll bet they exist somewhere. Here's the class diagram for the proverb class, which is quite simple. It represents a single proverb. It allows access to the proverb in game prompt form, such as "There is an old Klingon proverb, if you cannot control yourself." And it allows access to the complete proverb, such as "There is an old Klingon proverb, if you cannot control yourself, you cannot command others." It has a constructor, for which it takes 3 arguments: the full text of the proverb, the prompt for the proverb, meaning the start of the proverb, and the origin of the proverb. These are all fields. Let's jump into implementing this. To start, I'll launch Eclipse. When I launch Eclipse, it asks me to select a workspace. I'm going to choose my channel workspace. This is the folder in which the Eclipse files are stored, so if you want to go looking for them, you can pay attention to where that folder is, or direct it to a different folder to be your workspace. You can also find the workspace folder from within Eclipse. In Eclipse, I'm going to choose New Java Project from the File menu, and I'll call this Proverb Game. And I'm going to click Finish. I am not going to check the Create Module Info box, as this has caused problems in the way we write and share programs in my classroom. Naturally, you should follow whatever process your team or course uses. Now I'm going to right-click on the SRC or source folder and choose New Class from the Context-Sensitive menu. We can also choose New Class from the File menu. We're going to write this program in the default package, so make sure Eclipse hasn't suggested a package to you, and if it has, delete it. Once again, this is because this is a small program, and this facilitates sharing individual classes. Make sure the source folder is your project name /src. Give your class the name Proverb. Remember that Java classes are named with an uppercase letter, as in many programming languages, and it cannot contain spaces or any special characters that aren't allowed in Java identifiers. Do not click the public static void main string args checkbox, as we're writing a class designed to work with other classes. We're not writing a program that we're going to run. We're defining a data type that other programs will be able to use. Click the Finish button. You should see the class proverb.java under the default package in the SRC folder in your project, and you should see the text editing window for this class in the editing area. We can now begin implementation. If you don't see what I've described, for now the best approach is to delete your project and start over, making sure you're following these instructions exactly, and you see on your screen what is on mine. There are ways to fix almost every problem that you might be having without starting over, but this video is focused on creating a Java class. So try again and make note of anything you may have missed the first time. Let's begin with the fields. The dash or minus sign in front of the fields in the class diagram means that they're private, so we'll declare under the class header private string full text, semicolon, private string prompt text, semicolon, and private string origin, semicolon. Now, notice Eclipse has put some warnings in for us. If we mouse over, it tells us that we aren't using these variables. Don't worry about warnings until you're done writing your class. If you still have warnings, then look at them because you may have missed something, like closing a resource, or you may have declared a variable you never use. Let's write the constructor now. The constructor has a plus sign in front of it in the class diagram, so it's public. So public proverb, and then 3 parameters, and we want to make sure we put them in the correct order. Now, I recommend, and the Elements of Java Style also recommends, naming parameters that set fields to the same name as the field. So we will write string full text, string prompt text, string origin. And then within the constructor, we will distinguish the fields from the parameter names by using this, which refers to the object being constructed. So this refers to the fields above declared on lines 4 through 6. So this dot full text equals full text. This dot prompt text equals prompt text. This dot origin equals origin. Now let's write the 2 accessors, getPrompt and getProverb. Accessor identifiers often begin with the word get. These access some aspect of a proverb, which is why they're called accessors. Note that these don't necessarily access the implementation. The implementation is decided after we've already identified the responsibilities of the class. I've decided to implement this with 3 fields, but we need only 2 accessors based on how this class will be used. We're storing that information in 3 different fields. So we'll write public string getPrompt because there's a plus before the getPrompt accessor, and it returns a string. According to the class diagram responsibilities section, this will return there is an old origin proverb, and then the start of the proverb, and then an ellipses. So we'll write return there is an old plus this dot origin plus proverb plus this dot prompt text plus ellipses, and that will assemble the proverb prompt. Then to write the getProverb method, we'll write public string getProverb, and then return there is an old plus this dot origin plus proverb plus this dot full text. Now note that every time we refer to a field of the class, and if we were to invoke a method as well, we prepend with this. This is a good habit because it makes it very clear to the reader that we're referring to a field of the object receiving the message. If somebody jumps into a method, maybe from a debugger, and they're not familiar with the object, they'll immediately know when a variable is a field versus a local variable. Okay, let's add the Javadoc comments. I am doing this last because this class is simple and we were working from a class diagram, but it makes sense to put Javadoc in as you're writing code to remind yourself of what you're writing as you go, particularly if the class is long or you're writing stubs and there's code you'll need to fill in later. Eclipse helps with this once you've already written method headers. So before the class name, before each field, and before each method, I'm going to start a Javadoc comment with /** and then press enter. And you can see that Eclipse fills some pieces in for me, such as author, param, and return tags. Within each block, I'll write a description. This should be separated from the tags by a blank line. So for the top of the class, I'll write a proverb that can be used as a prompt in a game for the first sentence. The first sentence is going to be extracted by the Javadoc tool as the summary for the class, so we want to make sure it is a good summary. We can then elaborate on that. I'll take the responsibilities from the class diagram and put them after the first sentence. Allow access to a proverb for use in a game that allows people to complete a proverb and guess the correct proverb. Provide a prompt of the form, there is an old origin proverb, start of proverb plus ellipses. Provide the proverb of the form, there is an old origin proverb, start of proverb, end of proverb. And I'm just going to change that by changing the verbs to third person. So provides and allows. And I'm going to remove the dashes that made this a bullet list. and I'm going to put p tags between the bullets to add a blank line, as Javadoc is HTML. Now below, where the console is, I can click in the Javadoc tab and see how that looks as Javadoc. The tags in my description are a problem, as you can see. We could insert the character codes as we do in HTML. For example, ampersand LT semicolon and ampersand GT semicolon. And actually, as soon as I fix the less than, I can see the greater than, but I'll fix them all. I should probably come up with a better way to write where components are substituted into the output, though, to facilitate writing Javadoc. With the fields and methods, you want to provide contextual information. So for an accessor, you don't want to write simply returns prompt text, for example, because that's already obvious from the name of the method. So I will write for full text the complete proverb, both prompt and correct conclusion. For prompt text, I will write the beginning of the proverb, suitable for a prompt in a game. And for origin, I will write the location from which the proverb originates. For the constructor, I'm going to write initializes all fields from parameters, then a blank line, and then for the parameters, I'm going to tag the descriptions of the fields. So after param full text, initial value for curly brace, @link, hashtag or # full text. And I'll do that for all three. This is because I don't think I can offer any additional context beyond what's provided in the field description. For the two accessors, I'm going to explain in the docstring what is returned in the context of the game. So for the description for getPrompt, returns a prompt for this proverb, suitable for use in a game. And for the return tag, prompt of the form, there is an old origin proverb plus start of proverb plus ellipses. So the first sentence gives an overview, and the return tag is very specific. Note the use of this to refer to the object receiving the message. For getProverb, returns the origin and full text of this proverb. Return the text of this proverb of the form, there is an old origin proverb plus proverb. And as we work on these, we can see below what the Javadoc looks like. Sometimes it's helpful to see that out of context so we can imagine what a programmer using our class will see and decide whether it's going to help them use our class. Now let's write a client program that creates a few proverbs and tests out the methods. So I'll right-click on the src folder and choose New Class. And I'm going to call this Proverb Client. And I'll check the box for this to create a main method. I am not going to refer to this as a testing program because we'll use JUnit to test our classes, but not in this video. This is just a demo, and we will call all of the methods. So let me first declare a proverb object, and I'll call it proverb. So proverb. And now I'll need some proverb text to initialize that with. I'll use the Klingon proverb that I gave as an example. So proverb equals new proverb, open paren, and now I have to get the order of parameters correct. Let's check back. It's full text, prompt text, and origin. I'm going to copy and paste that parameter list in, so I'm sure to avoid mistakes. So for full text, it's if you cannot control yourself, you cannot command others. The prompt text is if you cannot control yourself. and the origin is Klingon. And you know, I'm going to go back to my proverb class and change that description of origin to make it clear it's an adjective. So we don't want to say there's an old Kronos proverb, or an Earth equivalent would be there's an old United States proverb, or there's an old China proverb, right? We want it to be an adjective describing the culture. There's an old Klingon proverb, there's an old Navajo proverb, there's an old Chinese proverb. So that information is going to help somebody using the class, because they might interpret origin as place of origin. So I'm going to change the description of origin to be an adjective describing the culture from which the proverb originates. For example, Chinese, not China. I'm not sure why, but the Oracle Javadoc guide says not to use Latin abbreviations, so I'm writing out, for example, rather than using e.g. If you know why, I'd be interested in the reason. When I was writing a textbook, the publisher made me change all of my for examples to e.g.s, which I thought would be less understandable to many students. Maybe the reasoning in Javadoc is similar. It's less understandable. Back to our proverb client, let's then send some messages to our proverb object. And I'll print the results. So I'll write system out print line. And then in parentheses, I'll get the proverb prompt. So proverb, the name of our object, dot, get prompt. And then open and close parentheses, and another close parentheses for the print line. I'm going to put some single line comments in. Create a sample proverb over the constructor. And sends the proverb some messages over the print line statements. Let's get the full proverb. So system out print line proverb.get proverb. And let's run that by clicking the green arrow. And we can see the prompt text and the proverb in the console tab. There is an old Klingon proverb, if you cannot control yourself. There is an old Klingon proverb, if you cannot control yourself, you cannot command others. Excellent. So that is creating and documenting a very simple class in Java using Eclipse from a UML class diagram. You can practice with this program by following the link in the description. I recommend you practice with this there, and also practice writing it completely from scratch in Eclipse. Try solving some of the exercises in the back of Chapter 2 of the open source textbook, Java, 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 Object-Oriented Problem Solving. I'll link it below. Once you can do that, you're ready to move on.